So let's go over these different functional groups. This is a hydroxyl. Hydroxyl, so these are things that are going to be attaching, let's say in this case, they're going to be attaching where these X's are, okay? So these would be things other than hydrogen that could attach. So you can have a hydroxyl, which is just an OH that's attaching, and it would look like that. So the one in blue is the one that is doing the attachment. These, then you can also have what they call a carbonyl. A carbonyl is a double bonded oxygen, and you can have it either in the middle of a molecule or you can have it at the end. If it's at the end, it's an aldehyde. If it's in the middle, it's called a ketone. All right. Then you can also have, see if I can get this in focus better. You can have a carboxyl. A carboxyl is COOH. This can also ionize, that is, it's giving off hydrogens. So what would that make it? It would make it an acid in solution. This is why it's called carboxylic acid. This is how it would look. Now notice it looks similar to an aldehyde. What's different here is the OH and the fact that it can ionize. All right? Then the next one is an amine. This is NH2. NH2, because remember that this is a polar molecule, it can sometimes take on the third hydrogen. So this would be removing hydrogens from a solution, or it may act as a base. This is called an amine, and it looks like this. All right. You can have a sulfhydryl. This is just has sulfur contained in there, and it would bond like that. And you can have a phosphate group. Notice that the phosphate group is charged, all right? So that would make it ionic, and it's going to tend to interact with other molecules, or that is easily dissolved in water. This is the phosphate group at the end of a molecule over here, all right? Now, the next thing that we want to talk about is something called enantiomers. Enantiomers are different ways, so you have the same chemical structure, the same chemical formula, but different structures. So these are what we call, not enantiomers, isomers is what I meant to say. So these are isomers. So this is a structural isomer. An isomer is something that has the same chemical formula, but it's arranged differently, in this case structurally, and we talked about branching before. This is a geometric isomer. So this is where the functional groups would be in different locations. So they have the same chemical formula, but the functional groups would be acting differently because they are in different places. And this is, down here is called an enantiomer. That's why I got confused, because I was looking at that. The enantiomer is just simply the left and right hand side of a molecule. A lot of times when you make a molecule, like chemically, let's say for example I wanted to make a bunch of vitamin C chemically in a vitamin C factory, I would end up with both the left and right hand side of the molecule, with only half of it being biologically active. So what tends to happen is only one form is biologically active. For example, in this case, this is DOPA, and you have the left DOPA and the right, and what ends up happening is there's only one biologically active side. So this is the biologically active one. This would be its enantiomer, not biologically active.